Hi there everyone, hope we're doing all right. So today what we're going to do is we're going to take a wee look through the 2018 National 5 Practical Metalworking paper as well as the marking instructions. So, there we go, close that. Hopefully we can see we've got the past paper on the screen as well as the marking instructions right there. So, as we can see, it's a 1 hour long paper and it is worth 60 marks. So, going into question 1 here, we've got question 1, a handmade screwdriver made of 2 separate parts is shown below. So we've got the handle and we have the blade. The blade is made from high carbon steel. High carbon steel is a ferrous metal. Explain what is meant by the term ferrous metal. So this is only worth 1 mark here, and the answer that they should be looking for is that ferrous metals contain iron. So if we go here and we look at the marking instructions 1A, ferrous metals contain iron, 1 mark. All good. Another 1 mark question here, state one property of high carbon steel that makes it suitable for the screwdriver blade. So all of our different types of material, I would be learning at least 1 property, definitely a couple more, but at least know 1 property of every type of material. So for high carbon steel, things that come to my mind is that it's tough, it's hard, it's also strong. So if we have a look, accept any one of the following. So we've got tough, hard wearing, durable, impact resistant, hard, can be hardened, can be tempered, strong, and any property that relates directly to screwdriver use, because it's mainly used for screwdrivers. Do not accept brittle and do not accept inferior resistance to corrosion. So these are the answers here that we will not accept, and you've got a large list of answers we do accept just for 1 mark. Question 1C, name each of the 2 common sections shown below. Now, this is a nice easy question, 1 mark for each. All it's asking is what shape is this bar? So for I, what I would say is it's a round bar, it's just a cylinder. And for I would put hexagonal bar because we've got a hexagon on the front there. So there, round bar and hexagon bar. For hexagon bar, it would accept any reference to hexagonal bar, example, a hex bar or a hexagon bar. So any of those answers they would accept it as well. Moving on to 1D, onto the second page now. The screwdriver blade was hardened and then tempered. Describe the process of hardening the screwdriver blade. So this is a 3 mark question here. So the process of it would obviously, to harden, you need to heat the metal up first. You need to heat the metal to a cherry red color, and then you need to cool the metal rapidly. So let's go on. I heat metal, the screwdriver blade is worth 1 mark. And then stating how hot you need to get it. So a hot cherry red color is what color your metal should be, and that's 1 mark. And then cooling rapidly is also 1 mark. Cooling rapidly, candidates may specify answer to cool in water or oil, quench in water or oil. This is acceptable. So as you're putting a hot piece of bar into either water or oil, it's called quenching the bar. But at the same time, quenching it is also cooling the bar. So they would accept cool in water or oil, or they would also accept quench in water or oil. Moving on to II now, we've got explain the effects of tempering the screwdriver. So what tempering does is that it reduces brittleness and it also reduces hardness, but all they're asking for is they're asking for 1 mark out of that. So either one of those 2. Naming the tools below, the tools are shown below were used during the manufacture of the screwdriver handle. So we have got tool A here and we've got tool B here. So what we have for tool A is we have a Jacob's chuck key, and what we have for tool B is we have a V block right there. So if we go in here, yep, I is a Jacob's chuck key and II is a V block. 1 mark for each. For I, they would also just accept chuck key. So you don't need to include Jacob's, but that is what it is. It's a Jacob's chuck key, but we just say chuck key for short. Moving on to F here. The machine shown below was using the manufacture of the screwdriver handle. So F, name this machine. Nice and easy. This is the center lathe. We should have all had a wee shot of it. Describe 3 safety checks that could be carried out in this machine before switching it on. So if you remember, most of the machines can use genuinely the same health and safety rules or safety checks. The lathe has a couple specific ones just for it. I guess we would need to make sure that the guard is down. That's specific for the lathe. Obviously, there are guards on pillar drills, but you don't need to use them all the time. So if we go in here and we have a wee look, we'll need to skip onto this page now. What they want is they want any 3 of the following answers. So obviously the guard must be placed in position. Difference for the center lathe is it must be positioned at all times. They have this in brackets though. So as long as you put the guard must be placed in position, that's fine. The material to be machined must be placed in the chuck securely. So that's securing your material. Chuck key must not be left in the chuck. Obviously, you wouldn't want that to happen. You wouldn't want a chuck key pinging halfway across the classroom. Check emergency stop, foot or knee switches, and make sure they're working. So always try, turn on the machine, make sure your emergency stops are working. Ensure feed mechanisms are not engaged before starting the tool. So obviously make sure everything's turned off. Make sure the tool's at the correct angle. Machine should be set at the correct speed, so obviously we can change the different gears to make it move at different speeds. Cutting tool is secure in post, so we've got our material as well as our cutting tool secure. Drill bit obviously secure as well, and any reference to checking parts of the machine for damage or missing. So always do a quick check over on your machine to make sure everything's in working order before you turn it on. Cool. Moving on to 1H now. So we have, let's see, handles A, B, C, and D shown on the machine opposite were used during the manufacture of the screwdriver. Identify the correct handle to use when carrying out the process shown below. So what we have, we've got our different tools right here. And we want our different handles. Now, the handles that it's referring to is back on this page right here. So we have A pointing to this handle here, got B pointing to this handle, C to this one, and then D to this handle right here. So for facing off, what we would use is we would use handle A. So handle A, this handle here, uses the compound slide, and we can use that for taper turning as well as facing off. So if we go in here, for I, we have handle A. For II, we have handle B. And for the next one, we have handle C. So handle A would be used to face off. Handle handle B would be used for taper turning, and handle C would be used for drilling. So handle A right there, that would be used for facing off. This one up here, I'm pretty sure I said handle A was the compound slide. That's my bad. That's that one there, handle B. And handle C right here at the end of the tailstock would move this drill in for drilling. Now, a 3-jaw chuck for holding the handle is shown below. So state the feature of a 3-jaw chuck which makes it suitable for holding the screwdriver handle. So the thing that they're wanting you to reference is that all of the chuck's jaws, these 3 jaws, move at the same time, and they can perfectly hold a cylinder for turning. So if we go and have a wee look at answer, all 3 jaws move at the same time, and another one you could have is that the 3-jaw chuck is self-centering, so it will make sure that your material is nice and center coming out of that. 1J, I think this is the last one out of question 1. The knurling tool shown below was used during the manufacture of the screwdriver blade, so that's going to be for the nice textured handle. State 2 procedures that ensure a high quality finish is achieved when knurling. So one thing I always like to remember when we're knurling, we always need to change the speed of the machine. We need to make it a bit slower. So for my first answer, I always put change the speed of the machine, because if you keep the speed up high, it's going to not leave a good quality finish with the knurling tool. So we always want it to be nice and slow. So that can always be 1 mark. Another couple answers that we can have for this, because keep in mind it's a 2 mark question. So set the center lathe to a slow turning speed. That's our first mark. Always remember that. We could use coolant on the knurling tool. We could adjust the pressure of the knurling tool, so how hard we're pushing it into our work, how deep the cuts are going to be. Tool must be the right angle to the workpiece. So obviously we want to make sure that it's sitting nice and flat against the worksheet. Always clean the knurling tool after use. Always check if your tool is sharp enough before you're about to use it. And we could also set a pivot pin of knurling tool to the center height. Now, moving on, we have a micrometer question. Oh, we're still on question 1. The micrometer shown below was used to check diameters during the manufacture of the screwdriver handle. 2 readings from the micrometer are shown below. State the correct readings. So all we've got here is we've got 2 readings of our micrometers, and we want to try and find out what they are. So the answers for those ones, 9.8 and 22.32. Now, as you can see, additional guidance, there isn't any, so they want you to get these exact answers. Usually there would be a bit of a tolerance, but right here, since it's just a nice clear picture of the micrometer, they want you to give the exact measurement. So we have 9.8 for I, and we have 22.32 for II. On to question 2 now. So a handmade door knocker is shown below. So we have supports, we have backplate, we have the grip, and we have the knocker plate. So the backplate has to be marked out as shown below on the drawing board. So we've got a sketch here of our plate drawn out. So that's that back piece right there before the hole's cut out. On to the next page. AI, describe how to accurately mark the radius 10 on the corners of the backplate. You must make reference to all tools, processes, and relevant dimensions. You may use sketches to support your answer. Now, like I always say, you may use sketches to support your answer. Just use a sketch. This isn't art. This isn't graphics. We're not requiring you to be good at drawing at all. All that sketching does is it helps the marker see what you mean, because you could be describing all of this with words and it might not make any sense. But if you draw a small sketch to it and then draw an arrow pointing to that sketch, it could help the marker piece it together. So 5 marks for this question. Now there's a couple different approaches. This is our type of question that you might get multiple different answers to. So we'll go and take a look at a couple of the answers. See 5 marks, and we've got 2 methods right here. So first method, you would get a mark for setting odd leg calipers. You would then get a mark for marking center lines, 10 millimeters from each ledge. Then center punch where the lines intersect. Obviously you want to do this at each corner, so they've put ×4. Remember, we don't need to write out full paragraphs. We can just write out these in bullet points. It's just wanting a step-by-step on how you would mark out the shape. So that's 1 mark there. And then set spring dividers, another mark, and to 10 millimeters on mark radii. So usually I would probably have this as 1 sentence, but that's just me. I would say set the spring dividers to 10 millimeters and mark the radius. So I would usually have that in 1 sentence, but you can see if you say set the spring dividers, that's worth 1 mark, and to 10 millimeters and mark the radius is also another mark there. So I would probably only have about 4 points for that, but I would still be getting the full marks for the setting the spring divider and to 10 millimeters. Method 2, we want to use a steel rule and measure 10 millimeters from each edge. Use an engineer square to scribe and mark the lines. Again, center punch our 4 corners. Make sure to say either ×4 or your 4 corners. Set the swing dividers, and again, that's our last mark there. Set the swing dividers, 1 mark, 2 10mm, and mark the radii as 1 mark as well. A cross section of the backplane showing the hole for a countersink screw is shown below. So that's this hole there. We'll assume that there's another one there, but we can't see it because of the grip covering us. But we want to figure out what is the purpose of using a countersink screw. So the main sort of point is, so the screw sits nice and flat and level with the surface of the material, so the screw doesn't stick up a wee bit. So if we look here, to allow the head of the countersunk screw to sit flush with or below the surface of the backplate / material. So that's 1 mark there. Moving on. So we've had a marking out question. Now it seems as if we're coming to a cutting out question. So this drawing shows how the grip was marked out prior to removing the waste material. So that's the grip, that's the handle, and we've got our waste material right there. Describe how to remove the waste material. You must make reference to all tools and processes. You may use sketches to support your answer. So obviously one thing I forgot to highlight on the last one, you must make reference to all tools and processes. If you just say you're doing things and you don't explain what you're using for them, you don't get any marks for that. So always make sure you use the right names and the right tools. So going on here, again, we'll have 2 different methods. Only a 3 mark question this time. Any reference to drilling holes to accommodate blades, using the hacksaw, junior hacksaw, to cut or remove waste material, or filing lines to the correct size. We could also use a chain drilling method. So chain drill along waste material, remove waste material with a cold chisel or a combination of hacksaw and cold chisel, and then lastly, again, file to the lines. So obviously, once we cut everything out, we want to file it and make sure it's all nice and even. Looking here, a flat file was used to shape the curves. Parts of the flat file are shown below. So it's given us the name. It's given us the name of the ferrule, the tang, as well as the safe edge. So we're not wanting to name these. Instead what we're wanting to do is we're wanting to state the purpose of each of these parts. So what we have the ferrule. Prevents the handle of the wood splitting. So the ferrule wraps around this wooden handle right there. That's a piece of metal. Tang goes inside, and this ferrule will stop this wood from splitting. It holds it in place so that the handle can sit nice in there. Then we have the tang. The tang is to locate and attach the file handle. So that's this stretch of material right here, and that's what sits inside the wooden handle. So this will run along the wooden handle so that a fair bit of material is actually connected inside that handle there. And lastly, we have the safe edge. That's just to make sure that no cutting is going on in that edge, so you don't go over. So prevent material from being cut during filing operations and protects thumbs, fingerings during filing operations. So it's like a safety edge, and also so that you don't cut material you don't want to. So explaining each of those gives you 1 mark each. On to 2C. So this is just naming the types of rivets we have right here. So what we've got right there, we have a pop rivet. You can remember that for the ball on the top. We have a snap head rivet, and we also have a countersink rivet. Remember the countersink because it's got this angled slope here. So let's go in, let's double check that we're right. Pop rivet, snap head rivet, countersink rivet. Perfect. Question 2, the tools are shown below are used during riveting. So we have tool A and we have tool B. So tool A would be a rivet snap set. We'll go in and check. Rivet snap set, perfect. 1 mark for that. And it's not asking us the name for tool B, it's asking us explain what tool B is used for. And these are small pincers to cut rivets to the right length. So to trim the end of rivets to the required length. So if we have a rivet, it's a wee bit too long, just trim it off. To continue again, the working drawings for the door lock are shown below. So we have the backplate, the knocker plate, the support, and the grip. Moving on, we've got a cutting list here. Using the information from the drawings shown opposite, complete the cutting list shown below. So we've got a number of the material, the actual material, which is all filled in for us. It's all made out of mild steel, length of the material, and breadth. So what we have here is we have the backplate. We've got one backplate. It's made of mild steel. The length is 100. We don't know the breadth, but the thickness is 3. So if we go up here, what we want to do is we want to have a look at backplate right there. And what we're trying to find out, we know the length is 100 and the thickness is 3. So there's 10 plus 80, that's 90, plus 10 is 100, so that's the length. The thickness of the material over here is 3. And what we want to find out is we want to find out the width. So this area here, and what I can see is I've got 10 millimeters, plus 40 is 50, plus 10 is 60. So for this breadth here of the backplate, that would be 60. For the grip, number 1, mild steel. Length, we don't know. Breadth is 30 and thickness is 6. So come up here to the grip. Width is 30, thickness is 6. We want the length of it, so we'll add 15, add 40, so that's 55, and then 55 plus 15 is 60. Nope, that is some bad maths by me. 55 plus 15 is actually 70. So in that one, we would have a length of 70 for the grip. For the support, we have everything apart from the number it has. So as you can see here, it's only showing us 1 support. But if we go up, I believe it was here to this one, because it's still all the same question. This is still on question 2. You can see we require 2 supports in that image there. So what I would go is I would go down here and I would write 2 supports are needed. For the last one, the knocker plate, number 1, mild steel, length 15, breadth we don't know, and thickness is 3.5. So this is the knocker plate. Breadth is 3.5. Length is 10. Length is 15, and width, nice and easy. Already got it there. It's 10. So let's go on and check. Yep. So we've got 60 breadth for the backplate, 70 for the grip, 2 supports, and 10 is the breadth of the knocker plate. Moving on, a couple of name the tools or machines. So the tool shown below was used in the manufacture of the door knocker. Name this tool. Nice and easy, that's a machine vise. And the tool shown below was used in the manufacture of the door knocker. Name this machine. So I believe for this one, they would accept pillar or pedestal. So we'll have a check. Yep, so machine vise was the answer for the last one. And for G, they would accept pedestal or pillar drill. So either one of those 2 for that. Explain why work areas on the floor around machinery should always be kept clean and dry. This is nice, easy, health and safety basics. We've got tons of different answers for it. Prevent accident, injuries, prevent slips and falls, and to access emergency foot stop. So always make sure that your work area is kept clear. Moving on again to question 3 now. So candle holder is shown below. We have the top of the candle holder and we have the body. The candle holder was made from recycled metal. State why is it important to recycle metal whenever possible. Give 2 reasons. So the reasons that they're wanting you to mainly look at for this is the recycled metals can be used for upcycling, saves finite resources, stops metal ore running out. Obviously, we have a limited amount of resources. The more recycling we can do, the better. Less damage to the environment by mining. Obviously, mines take up a large portion of underground work. So less we do that, the better. And landfill sites are not filled up as quickly, so fewer landfills needed. So less junk lying about. 1 mark for each unique point. So if you were to give 2 points about mining, you would only get 1 mark for that. The answer is a general comment regarding the environment. Only 1 mark can be awarded. So even if you're unsure about this question, just if you say it helps the environment, it's a general comment regarding the environment, so you would still get 1 mark, but obviously we want to aim to try and remember these 4 here. They're our main ones. So 2 of those to get the answer. Describe the test that would distinguish between mild steel and aluminium as part of the recycling process. So we would want to obviously test which one is magnetic or not. So that's a way that you could tell which one. Obviously, if you wanted to split them all up, just hold a large magnet above it, and one of them will separate from the other. Now, test which metal is magnetic. Now we're on to question B. The body shown below was made from 1mm mild steel sheet. So we've got our waste material at the corner, and we have our waste material there, and we've got a couple bend lines. So that's this shape on top here. Name a hand tool that can be used to remove the waste material before finishing with a file. So we have a small bit of material here. We could use a tool before we go to filing. Now, there's a lot of different tools that we could use for this, a couple different answers, and all they want is one of the following. So either tin snips to cut it off, a hacksaw, or a junior hacksaw. So any of the 3 following to cut that bit off, that small waste material. Question 3 continued. The surface development and stage of bending the body are shown below. So we have our fold lines, and we're starting to bend this now. Describe using correct terminology how a bend A is formed. You may use sketches to support your answer. So another one here, only a 2 mark one this time. What they're wanting is you're wanting to align the fold lines with an engineer's vise, folding bar, jig, straight edge, box folder. So there's a lot of different methods that we can use to fold metal. So I'm going to go ahead and talk about a box folder for now. So what I would say is align the fold line in the box folder. That would be worth 1 mark. Form bend A with the box folder. And that's it. And that's our 2 marks there. Same with if I wanted to use it in an engineer's vise, I would say align the fold line in the engineer's vise. That's 1 mark. Form bend A with a rubber mallet. So if I had it in the vise, I would be hammering it with a rubber mallet, obviously rubber, to make sure there's no dents in my material. And that's how I would form it that way. So as long as you're saying that you're aligning the lines with whatever method you're using, and then you're forming it using your method, and that's worth 2 marks. On to 3D now. The top of the candle holder is shown below. Explain why the hole is drilled in the top before bending it to shape. So 1 mark for that. Except any of the following, it's easier to locate the hole or drill when the material is flat. There's less chance of the drill slipping. Material might deform, so if we were drilling down on that and it's already bent, it might end up bending the other way. And it's also easier to hold the material when flat. So common knowledge, why do we not drill on curved surfaces, or why do we prefer to drill on flat surfaces? So 1 mark for that one. It was decided to make a pair of candle holders. E, state the method of ensuring that both tops are bent to the same shape. So we would accept any of the following: using a jig, using a former, or using a template. So I would usually say if we have a template, we can start to replicate multiple versions of it, working off of the same template. 1 mark for that. State 1 health and safety precaution that should be taken when working with sheet material. So when we're working with sheet material, got to wear goggles, wear safety, wear gloves, and remove sharp edges. So obviously sheet material is really thin, it'll have a really sharp edge on it, so quicker we can get that sharp edge away, the safer it will be to work with. On to our last page now. We have question G. All this tool is a notcher. So it's a smaller version of the guillotine, and that's why it's called a notcher. Describe 2 stages of preparing sheet metal for a finish. So we've got 2 marks for 2 stages right here. And they would accept any of the following. So deburr the edges, so clean all the sharp bits of metal away. File the edges nice and smooth. Use an emery cloth, rough, medium, fine grades. You could use wet and dry sandpaper, degrease, prime coat it, or we could use some steel wool as well. So any 2 of these answers. Usually I would go for the nice simple ones. File the edges smooth, and also use your wet and dry sandpaper. Back to the question paper. State a suitable finish, which could be applied to sheet material. Any type of finish we can think of, really, for this one, except any of the following. We could paint it. That's a nice, easy one. Remember, it's only worth 1 mark, so if we just put paint, that would be nice and simple. But we could also dip coat, we could lacquer, we could polish, we could bluing, and any other appropriate finish you could think of. But I would just be going for a nice, simple one just for paint, just to get that question over with as quickly as possible, save you some time for the others. Explain why blunt tools can be just as hazardous as sharp tools. So this is our last question here. It's worth 1 mark, and they would accept any of the following. So the tool doesn't function as intended, so it's not functioning properly, which can make it become a little bit dangerous. Extra force is needed. So say if you are sawing something and the saw blade's not as sharp as it should be, that's you putting more pressure down on the material to give it a better cut, which means you have more chance of the material snapping, maybe the saw blade snapping, anything like that. And obviously, if it's not sharp, it won't cut, so it could slip, which may result in injury as well. So any one of those. So hopefully that was good and informative for you, and hopefully you all know what you need to do to get full marks on the 2018 past paper. All right, see you.